In this video, we're going to be doing an FRQ on a hydraulic lift in AP Physics 1. So here we have a man pushing down on a piston, which is going to force the fluid inside of the piston to rise from B to C, and that will cause the car to move upward because the platform will push up. So we have that our system is at rest and our pistons are massless. We want to first draw an FBD for the piston that is labeled B. So for piston B, we are going to have a downward force from the man. We'll call this F man, and we're going to have an upward force from the fluid, buoyant force fluid. Now, if we use Newton's second law, we have that the summation of our forces in our vertical direction is equal to ma. So we know that it's massless, and we know that the pistons are at rest. So then the summation of the forces in the vertical direction are equal to 0. If we make our upward direction as positive, then we're going to have that the FB of the fluid minus F man will equal to 0. So then we can see that FB fluid is actually going to equal to F man. So then the FBD for B, again, we have an upward B fluid, downward F man. So the small piston here is in equilibrium. So the upward fluid force is going to balance the man's downward push. Now for our piston C, it is also going to be massless and at rest. So we're going to have an upward force on this piston. We'll call this FC fluid. And then we'll have a downward force. We'll call FG, M car times G. So we have that Newton's second law, summation of forces in the vertical direction are equal to 0. Taking upward as positive, we have FC fluid minus M car times G is equal to 0. So you get that FC of the fluid is equal to the mass of the car times G. So for this FBD, we have that the large piston is going to be in equilibrium, so the fluid is going to support the weight of the car. Now for 2, we are asked the areas of the piston are A, B, and A, C, respectively. The pressure in the fluid is going to be P. We want to write the expressions for the upward force of the fluid on piston B and on piston C. So this is area B, this is area C. Okay, so for 2A, we have pressure is equal to the force that is perpendicular over area. So in order to find the force from the fluid on the piston, we can multiply both sides by A. So F is equal to the pressure times area. So if we do piston B, we're going to have FB fluid is equal to the pressure area of B. Now for piston C, you're going to have that FC of the fluid is going to be PAC. So pressure times area gives force exerted by the fluid on each piston. For part B, we're asked to find the force for which the man is pushing down. Well, because we know that piston B is currently in equilibrium, that's where we got the F man is equal to the FB fluid. So that's how we knew F man is equal to the pressure times the area of B. Piston C is also in equilibrium, so force C fluid is equal to the M car times G. FC fluid is equal to PAC. PAC is going to be M car times G. So then if you solve for pressure, that's m car times g over AC times AB. So pressure is going to be the same in the fluid throughout. So the small piston needs a only smaller fraction of the car's weight force, and that's going to be scaled by our area ratio. Now 3, we have that if the man pushes just a bit harder, the car will rise. Now let's say that the man has pushed downward by an amount x. How much higher up is the car now? So we have conservation of our fluid volume. What that means is that the volume pushed down on the small piston is equal to the volume pushed up on the large piston. So what you can describe is that the change in volume on piston B delta V, B is equal to A, B times X. So H is going to be car rise. So then our change for piston C in volume is going to be AC times H. If we set them equal, we have area B times X is equal to area C times H. H is equal to area B, X, over area C. So this is how much the car rises. The reason is because our fluid is effectively incompressible. So the volume moved down on one side must equal the volume moved up on the other side. So now for part 4, we're asked the definition of a simple machine is a basic device that changes the magnitude or direction of a force. Explain how this setup is a simple machine. Well, our hydraulic system is going to change the magnitude of the force because a small applied force, so the small area piston produces a much larger force on the large area piston. Basically, it changes the direction of the force because the man pushes downward, but the car is lifted upward. And what we saw from part 2 was that FC is equal to PAC, and that FB is equal to PAB. That means that the ratio of FC over FB is equal to AC over AB because pressure cancels out, So then if we have that area C is greater than area B, then we can know that FC is going to be greater than FB. So that means that a small input force can lift a large load. So overall, the system is a simple machine because it's going to let the person push down with a small force on the small piston, and then the fluid transmits that pressure to a larger piston, producing a larger upward force that is going to lift the car. It also reverses our direction of force because the downward input becomes an upward output. So the hydraulic lift is going to multiply that force through the area difference and is going to reverse the direction from down over here to up.